Okay, as in the previous exercise, we have connected to the supercomputer and we have entered in the exercise 2 folder. So here we have the same methods, and we can see that in this case we already have defined the task and these kind of things that we have done in the previous exercise. So as I have explained before, what we have to do is to modify the block class implementation to parallelize in the CPU the block multiplication. To do it, we have to enter to the source code of blockcc. Here in this case we see here the multiply block, and we can see that this is a nested loop, and what we can do is to make a task, one of these, for instance these two loops as a task, make this piece of code as a task. To do it, what we have to do is to add the pragma just before the code that we have to define as a task. And in this case, as we are not we don't need to define dependencies, because all the loops are defining are tackling independent data. So they are generating the ij data and all the others are shared. So we don't need to add the dependencies. So finally, what we have to do is to synchronize at the end of the execution of this method, in order to have all the data synchronized at this point. So we have to add the pragma task weight, OMP task weight. So, and that's all in this case, to parallelize. However, if we compile and run only with this modification, what we will have is that we have parallelized the CPU, but the runtime will only assign one CPU for this, one core for this task, because it's the default constraints. So if we want to run with several cores in parallel, what we have to indicate is to the runtime that we want to use more than one core in this for this task. So, and this is done in the specifying a constraint in the interface where we define the task. So in this case we open the matmul IDL again, and we have to add a constraint in this for this task definition. So for instance, we can add this constraint. Okay, this constraint says that this task uses a processor that is type CPU and 3 computing units, that means 3 cores. Okay. Now it's time to compile, so it is done with cons build up, now with the ohms flag and matmul. So in this case we will see that we compile the application with the Mercurion compiler here, and we are doing some of the things, so adding the calls of the nanos runtime to the where we have put the pragmas. Now we have compiled the master, and now we are creating the worker part, as we did in the other exercise. Okay, we can see here that we are using the Mercurion compiler and doing all the ohms stuff. Okay, now we have finished with the compilation. It's time to execute. In this case we are going to submit with enqueuecoms. Okay, the job is running and we have to wait a little bit until the job finishes. We are going to, so in this case we have waiting for the blocks. Oops, sorry. Okay, the application has finished and we can see that we have reduced the execution time. So if we go to Slurm, so the application has finished and in this case we have sped up the execution because of the parallelization.